Okay, so here's problem 4. So let me draw this out. I had already thought about this ahead of time. So the maximum acceleration without anything sliding off will be as you accelerate the truck, there's that cable, so the top one can't move. So the bottom beam is the one that's sliding out. And so what we're going to have when you're accelerating is this beam will slide out during the acceleration, positive A. When you slam on the brakes, either the bottom or the top beam will move forward, but you can see that the coefficient of friction on the top beam is less than the bottom beam, and so we're going to have the top beam slide forward when you're decelerating. Okay, so I'm going to do problem A first, and so I did it by drawing 3 free body diagrams. The two together, which weigh 8,000 pounds. And so remember the bottom beam is sliding out, so the friction is opposing it this way. And so the friction on the bottom was 0.5 times nu because it is on the verge of sliding. Okay, then I did just the top one like this. Okay. And that one is also accelerating. And that'll be the mass of 2 of them. That'll be just the mass of 1 of them going forward. And this one weighs 4,000. There's N. And so the bottom beam is sliding out. So it's going like that. 0.4N. And then I did the middle beam, which does not have the cable on it. And there we go. And so, and I was starting to get confused with the different normals. So I call that normal 1, and I call that normal 2. And so if you look at it, you have, let's see, you've got the flip of that. Okay, so that's normal 2, 0.4 normal 2, and you do have normal 1 and 0.5 normal 1 equals that. Okay, so there were 3 free body diagrams. And so and this one has a weight of 4,000. Okay, and so I did sum Fy equals 0 because there's no y acceleration for the first free body diagram. And so I had minus 8,000 plus N1 equals 0, so N1 is 8,000. Then I did sum Fy equals 0 because there is no y acceleration for the second one. And I got minus 4,000 plus N2 equals 0, or N2 equals 4,000. That might have been obvious to some of you, but I just wanted to write it out to convince myself of that. So now, if you look at free body diagram 3, I did sum Fx equals Max, and you get, let me draw it all out again. We had the N2, which was 4,000, you had the weight, which was 4,000. You had the normal on the bottom, which was 8,000. That's nice. That adds up to 0. And then we had, oops. Let me draw those four, write out 4,000. And so then we had 0.4 times N2. And we had 0.5 times 8,000. Okay, and that was going to equal MAX. So, just taking the components, we get 0.4 times 4,000 plus 0.5 times 8,000 equals the mass, which is 4,000 over G times AX. So, sad to say, when I flew through the test as fast as possible, I wrote 8,000 instead of 4,000, so I got that wrong. I think if I was grading that, that would be, I don't know, 2 to 3 points off, 1 more point for the answer being wrong, and then 2 more points off because you're going to get T wrong, or 1 more point. So that's probably a 4-point mistake right there. Okay, so anyway, solving for AX, you get 0.4 times 4,000 times half of 8,000, that's 5,600, all over 4,000. I had 8,000 there, so that's how I got it wrong, times G. So there we go. That's 1.4 G. And this problem was in feet second pounds, so 1.4 G. Yeah, times 32.2, 45.1 feet per second square. Okay, so now we can pick any one we want to get T. I don't know. Let's see. Let's do free body diagram number 2. So from sum fx equals max f free body diagram 2, we get T 4,000, 1,600, and that will equal 1.4 G times M. So 1.4 mg. So 1.4 times the weight, going that way. Okay, so you get T minus 1,600 equals 1.4 times, the weight for that one was 4,000. It was just one block. Okay, and so T equals 7,200 pounds. Okay, so we get 7,200 pounds. Now it's time to do part B. And so in part B, I had convinced myself that the top block was moving forward. So 4,000, the normal, and E times the normal. And that was going to equal mass times acceleration going that way. And so sum Fy is 0 because there's no y acceleration. N is 4,000. Mu times N, it was 1,600. And so sum Fx equals 0. We get minus 1,600 equals minus 4,000 over G times A min, and so you get A min equals 16 over 40 G, and that equals 0.4 G, which is 12.9 feet per second squared. 0.4 G equals so that's going accelerating and decelerating. Okay, so here's the last problem.